All right, Jonathan. Just was making sure this is the right link.
What?
I was just making sure this is the right link. It's
Yeah. Right. Hello, Sammy. How are you?
Hello, how's it going?
Pretty good.
nice. Hi, Sammy. Where are you located?
I'm from Westford, Massachusetts, and I've unfortunately been stranded at home for the past 4 months, so that's why.
Actually, you know what's so funny? Actually, if you start biking, you can be reaching us in 20 minutes.
Yeah.
We are from Acton.
Oh, that's really cool. Actually, I think I have a friend that's working from Acton that's working with the hackathon. So yeah, neighbors.
Ah, okay. Yeah, we're just gonna give some more time because you're the only one so far. Yeah, four
Yeah.
So you're the only one want to be cloud ready, huh? Nobody cares about cloud.
I'm sure that's not. I'm sure they're hard at work, on their projects.
I'm sorry?
I'm sure they're just working really hard on their projects.
Oh yeah.
Yeah, that's true too. Maybe the timing is a problem. I will see. I mean, we can definitely talk, but maybe Jonathan, if we have only few, we can reschedule it to I don't know tomorrow because I'm
And tomorrow there will be even less people. If everyone's just like racing to get things done. Like right now, everyone's like, "Hey, I've got some time. I've got some errors. How about I take a break?" But then it's just like sweat is running down, and they're just working.
Yeah, I understand. But anyways, I mean, don't worry. We'll still. I mean, you may have it be very special because you may having a one-on-one session.
I would love that.
Hey, this is actually what Suresh does to AWS customers. He's kind of like a sales support person, so he would just help out customers like one-on-ones.
Yeah, so you have to pay me though. We charge a lot of money. But anyway, I think it's interesting. So I think we'll get started. So instead of me talking, like I'll definitely share a presentation. But Sammy, tell me what you know about cloud or what's your perception. This is not a test, by the way. This is to see. I'm here to educate you. So tell me what you think is cloud is, and how do you think it's important, or how would you think that is changing the world, in your opinion?
Well, actually, I'm here because I know very little about cloud, and I wanted to explore what was beneath the buzzword nature of it. And so my
okay.
limited understanding of it is just that it's like data storage or management or server space that is like distributed like through a network for some central unit. But I guess I'm curious as to how it's just different than other like distribution of resources and what makes it different. I know that it's not directly on the computer, so it doesn't take up storage. But yeah, I was just curious as to what made it unique.
Okay, that's good. That's good. So maybe I'll ask. Kevin is one of the organizers along with us. But Kevin, what do you think cloud is?
I'm actually not really too sure if Kevin is actually there.
Oh, okay.
The recording.
Oh, maybe it's recording. Okay.
Yeah.
That's fine. That's fine. So
Jonathan,
by the way, Jonathan and I, we've been working for, I don't know, past 6-7 months. My son is another organizer, and Jonathan is. So anyway, I will start going through a presentation. But, yeah, definitely that. At least I can guarantee that you'll walk away with that answer. Let me see now how this screen
hey,
sharing.
Sammy, are you part of Storm Gears?
I did it in middle school. I think I was part of the Blue Storm Gears, and then our friends and I started our own competing team. But I was part of the Blue Storm Gears in 6th grade, I remember.
Oh, join Storm Gears FRC. You'll see me there.
I'll be sure to. It's too late for this year, though, right? Or
First Robotics this year they kind of canceled, but next year maybe they'll figure something out. But anyways, it's just a great team. So join. I'm part of the outreach team. Vid is also part of it. So yeah. Okay. Sorry, that was a bit of a tangent. We should.
No. That is fine. That's fine. Anyway, I'm just setting it up. I wanted to make sure I'm 2 monitors. It's kind of interesting how it kind of does this. But anyway, I have 3 competing with Jonathan. We have Kara and Morgan. Welcome. All right, I think we'll get started. Hold on. I'm definitely struggling with two monitors. All right. Are you guys able to see what I'm seeing?
Yes.
Okay, perfect. So anyway, for those of you, we're going to talk about, if you make sure it's the right session, we're going to talk about cloud computing, what it is and what it's not. My name is Suresh Sankar. I'm one of the organizers. I'm also a technical account manager for AWS. So I work with customers who have adopted AWS but want to make sure they use it correctly. So they pay a fee. So in Boston, I live in Boston. We have like 3 customers I work with, and I meet with them and try to educate them, help them to architect, and help them to run cloud effectively. So pretty much, I kind of work hand in hand with their customers. Cloud or IT department. For example, let's say it's Pfizer. If you know a company called Pfizer, it's in the Massachusetts area. They developed drugs, drug discovery. So I work. Let's say they are adopted cloud. I work with them and make sure they're using the cloud effectively. So that's my job. I live in Acton, Massachusetts. I'm one of the organizers. I work with Jonathan and others. All right. So a little bit about me. I studied in India. Um, I also have a degree from Harvard. I did not get a degree in technology, but I found people's behavior and understanding people is not Googleable. So I realized that I'll go to school for that. So I did a master's degree in organizational behavior. I I worked in a lot of industries. It's been 25 years, but predominantly last 6-7 years, I worked in Dell EMC. After that, I worked in Microsoft, and then now I work for AWS. Um, in terms of passion, I'm a big basketball fan. I really miss basketball because of the virus thing, we're not able to see. But they are starting the season end of the month in Orlando. But that's not looking forward. But I also play tennis for fun. I'm just playing for recreational tennis. So today we're going to talk about from basics, right? I'm definitely going to take you to cloud, but before cloud, what are the different things and how things work today, and then introduce you to cloud. And also, I'm going to introduce you to some AWS developer tools, like things you'd use for development and how cloud can help you. And last but not least, we're going to talk about AWS Educate, which is basically some credits you can use it to get some certification or learning paths if you want to learn more about cloud. So those are the things I'm going to talk about. All right. So as we discussed, we're going to talk about cloud, right? So what is cloud? So trying to make it interactive, but does anyone know how the stuff in your phone like Fortnite, Netflix, Snapchat, Instagram work? Can anyone in the call, if you want to unmute yourself and explain? There is no brownie points for answers. Everything. We just wanted to see if you have any kind of knowledge about how things work behind the scenes. If you want to say anything, you can unmute yourself.
They all.
Go ahead.
Sorry. They all use. I believe they all use AWS for like backend services to host their web traffic, and because like in their backend because they might not have the capacity to do so. So all their services like kind of use AWS to like operate all of their information.
Yeah, they might use, but do you know in behind the scenes how they work? Like what really happens when you go and look? I wanted to watch Stranger Things. What happens behind the scenes?
I have an idea. Or
Right.
yeah, go ahead, Sammy.
Just to clip like how the internet presents information, or just
Yeah, how things work back on, like when you type something, what happens behind the scenes? When I go and Snapchat someone or DM someone, what happens behind the scenes? No problem. If you don't know, I was just trying to make sure we are engaging everyone in the call, but that's fine. Thanks for, you're almost right. But so for example, let's say you have a mobile device, right? Like you pretty much, you have a Wi-Fi when you're home, or like a 4G when you're outside, or you have a physical internet connection. It basically goes and hits the data center. So assume this data center is a physical thing, it's somewhere hosted in, if you look at Boston, there is within the downtown Boston, there are companies which host data center where they kind of host servers, storage, memory in their data center. And then in that data center, if you really see in the picture, you have what I call the application software. It could be Google Docs, Facebook, Instagram, all this soft application code is running in the data center. So when you go and you know want to really access something, you're pretty much hitting a data center which hosts the code, and then you traverse back and if data is presented or information is updated. So most applications work like this. So your connection between you and the data center, it's sometimes you can think of it's a physical network, but you are not directly interacting with that, but it's pretty much hitting a data center. So that's what I wanted to get at. But what we are really talking about today is this is replaced by a cloud provider like AWS, right? Instead of we hitting a data center, we are hitting a cloud provider, which again is a cluster of data centers, which is not different from it, but it's a little bit different from way it's organized. But pretty much in the sense, like if you are just, for example, we all know many of the, like Fortnite is a AWS customer, so it's publicly available that they are our customers. So it's pretty much when you say want to play a game using the Wi-Fi or your physical internet connection, you're hitting AWS, and AWS servers or AWS infrastructure host these things, and then you get back the data what you're really trying to access to. So that is the way things work behind the scenes. Any questions on that? Anyone? There's no dumb questions, by the way. Every question is a valid question. We are all learning together here. Okay.
One quick thing.
Sure.
I can see like the next slide thing. Are you sharing the right screen? Or it's fine if it's supposed to be like that. I was just curious.
Oh yeah, I think you are seeing the next one. Yeah, but I see what you see, but I don't want to change anything, but it's fine at this point. Okay. Yeah. All right. Cool. So what are devices, right? Like we have all these devices. I'm just going to get into what are the devices we use in a daily life, right? Like we use laptops, we have tablets. Most of the things displays information. It pulls information from something, or you have a form, you submit it. So these are the, I would say, consumer devices. I will call them infrastructure, but they're consumer infrastructure that we use. So this is something we use on a daily life, right? So what is the difference between what we use as a PC or right now you're at home, use your PC, you access applications, right? The servers themselves are the key components in a data center, right? So these are the servers. As I talked earlier, as a user, you use internet to access these servers that is sitting maybe in Boston or maybe somewhere in the world, right? So that's pretty much when we talk about what is a server, it's the difference between an application or a server. So just to get some grounding on the terminology or what it really means. Any questions, anyone, so far? Sammy, so far so good?
Yeah.
With me?
Yeah.
So in terms of what is infrastructure, right? So it hosts the information. Sometimes we use storage. The compute is basically a server, when you say a server, it has memory, CPU, and then we have storage. Just like when you open your laptop, you have some D drive, C drive. Think about that, storage. So all these things in an infrastructure, it could be a storage, which holds your data, a network which communicates within the data center or within your personal device. So we need a network. We also need compute, which is basically CPU and RAM that kind of process this information and sends them to the right places. So this is pretty much what an infrastructure means. So today we can pretty much think about in a data center, we build them or it is built for you by the data center. But in the cloud world, it is built for you. For example, when you look at data center, this is actually in the right-hand side, you see a picture in Waltham and Cambridge. These are data centers right now. we have them, but they are managed by some companies. Either it is sometimes companies like Pfizer would pay for it, or they would rent that space from someone. So pretty much a data center looks like this. So they have coolers, they have all these servers, racked there, and we can host this application. Sometimes it could look like this, but inside it's all like all these racks of servers hosted, right? It looks like a warehouse. They have dedicated power and cooling. So, like we talked about data center and we talked about cloud, right? So, what's the difference? So, when you look at data center, it's almost like you building that, being a pizza at home. I know a lot of us during this quarantine started cooking, right? Instead of going to the store. Either you couldn't go to the pizza, but you were afraid to go, so you started making it. Think about data center is something that you traditionally companies who were building infrastructure is like making pizza at home, right? So you know what you want, you make it at home, and then you have more control over it, right? But you can also think about cloud as you buy the pizza from home because somebody is making it for you and you're just consuming it. They take care of whether the cheese and the food and all this is a good quality. They make sure it's not contaminated. They make it fresh. You just pay for the use, right? Like you just pay and then get the pizza, right? So you need to think about cloud as a buying pizza from pizza shop versus data center as a making pizza at home. Just a simple analogy, right? So before data centers, right? Data centers, people used to buy all these hardware networking from Cisco, server from Dell, IBM, EMC for storage. So we need to put the things together. And it was very expensive because let's say I'm a company like Pfizer, my core competency is drug discovery, right? It is not about building infrastructure. So companies are questioning themselves, why you need to spend so much money on building data centers? So this is pre-2008. That's where people are like questioning why we need to build our own data centers. Why can't we buy the pizza rather than by making it home? So here comes AWS or any kind of cloud provider. We have other cloud providers like Azure, Google Cloud. But the point is, whatever you want, whether you want to develop a business application or a gaming system, you want to build a database, you want to have developer tools, you want to do monitoring, even if you want to do robotics, like for example, you want to stream something, everything is there. Everything is pre-built for you and you pay per use, right? So you don't need to go and buy the pizza, make it at home. All you need to do is think about these Lego blocks. Based on application needs, you kind of put things together and use it. And also you pay it by the minute or hour. You just pay like electricity bill, power bill, like you pay per use. Before you go further, any other questions anyone has on what cloud is? Is it helpful? Is it clear?
I had a question
Sure.
or some clarification.
Sure.
So I understood the part about how like when you request assets or any resources when you're using the internet, it goes from a data center. And it might be because I logged off, so I didn't see the last slide, but is this how the internet worked before cloud, or what makes like AWS different than a data center that's like sending resources through the internet?
We will talk about that. The premise is the same. The benefits is what I'm going to do. Still going to cover.
Okay.
So one of the things is, that's a good question, right? One of the things is, let's say I am building, buying hardware, right? Like, so if Amazon is buying or AWS is any cloud provider buying hardware, I can buy at scale. For example, I could buy so much that the cost per storage unit is almost less. Any company in the world, let's say you are like a Pfizer or you're like even you are like CVS, you can never buy at that cheap cost because I'm buying large quantities. So I can buy the hardware at a very low cost, or if I'm manufacturing myself, the cost will be very low because it's like buying from BJ's versus buying in Market Basket, right? Like it's because the scale of things, I can do it for cheap cost, but also I can also innovate and I can also making it more consumable, right? Like because let's say you want to do a project, right? And you have to pre-buy the hardware before you do a project. With cloud, you don't need to. You just need going to pay per use. And let's say you start a startup, and let's say you have an idea, you build it. You're not investing a lot. You're just building a little bit, As a company grows, you go more. But in the traditional world, you have to invest on a data center. You have to pre-commit the infrastructure costs. So those are the benefits. And also the other benefit to you, let's say I want to have like Netflix, for example, right? I want to have my Netflix users in China and India and US have the same thing. If I have to build Netflix today pre-cloud, I have to build data centers all over the world. That's going to be very expensive, right? But since it's AWS, they have built data centers all over the world. I can really have a deployment in China and then have the users go there. I'm kind of simplifying things a bit, but that's the power of cloud, right? Because it's gone are the days I build my data center for my own users, but somebody's building for them, building for me. I'm just using it whenever I need it, wherever I need it.
So
Does it help? Go ahead.
So it's basically like licensing out the technology to companies who need it instead of making them have to build it themselves, which is like,
yes.
Okay.
It's very, very expensive. I mean, it's very capital expensive. I mean, if you really work in a company that is the infrastructure expenditure could be extremely high. And I'm not saying, cloud is still you to pay, but you have to make that upfront commitment. You never know if a company is going to be surviving, or you never know that you'll be using that, because sometimes projects don't go well, right? Just like anything else, because a lot of uncertainties.
Okay, thank you so much. That cleared it up a lot.
Yeah. So what is cloud, right? The another analogy is, as I said, there are data centers all over the world, right? So if you're in California, you're starting a company, you can just point the cloud to say, hey, build infrastructure here. I'm in Brazil. I just want my users are mostly in Brazil. I can still be in Massachusetts and build infrastructure in Brazil. You can't do that in a traditional world, right? You have to go and physically build infrastructure. Same thing, right? So we have regional things. And also, let's say we also bring disaster recovery in build. Let's say you are in East and there is West. So something happens, a catastrophic happens, I can fail over directly to the West region or vice versa. Right? All these things are there for you from day one. You don't need to worry. I mean, you still have to deploy infrastructure or do some configurations, but this is the power, right? And also there are some disadvantages, or even like what I call like some limitations, right? For example, I don't know, any of you live in an apartment right now or a condo? I don't know, have you lived in an apartment? So let's say when you live in an apartment, you have to follow certain rules, right? You can't, I don't know, put an antenna, or you can't put things wherever you want, because it's a shared infrastructure, or the building is shared, you're sharing walls. You have to go by some rules, right? So, for example, cloud is kind of a multi-family apartment, right? Whereas data center is like a single family home. You can do whatever you want. You can reconstruct it. You can topple it, or you build an extension, additions. You can build a patio. No questions asked. But the problem is the scalability and the economies of cost, economies of scale will not come through. So, so that is a kind of another analogy of building like a public cloud versus a data center. But when we say we call in a cloud, we call it region, but region is basically, at the end of the day, it's still a data center, right? We build it and we have some automation around it and we can scale better. But at the end of the day, a cloud is still a cluster of data center built and leased and provided for a cost by someone else. So that you don't need to worry. All as if you're a startup, you're a developer, you just need to think about your idea, how fast you can develop them, how fast you can sell them and make money out of it. All the other responsibility, still there's a shared responsibility, but bulk of the infrastructure responsibility goes to the cloud provider. And also you just pay for use, right? You're not putting upfront of millions and millions of dollars to build something. Whenever you use them, you pay. That's it. Right, so this is just another picture. So this is where we have all these regions or data centers all around the world. That's why we have this. Obviously, each of these are very expensive. We're looking at some billions and billions of dollars of a region, but because we have pre-invested and because of the scale of the business, AWS operates, we're able to offer it, and we keep on expanding to other parts of the world. So in a traditional data center, you cannot. It's very difficult or very expensive to build this at this so much scale. For example, one of my customers is building. They're sitting in Boston. They have customers in Australia. They are building infrastructure for users in Sydney. This is, I mean, and at just a click of a button. There's no waiting time on anything. So this is not possible in the pre-cloud era, right? So anyway, so what is different with AWS is probably the first, probably enter the first in the market. It's very comprehensive. Companies use them to for the infrastructure and be very flexible. Because also another thing is, if you don't need infrastructure, you can just deprecate or delete it, right? So you know, in a pre-data center, pre-cloud era, you cannot just throw things off what you bought. It's not like returnable, right? And also, you can shut down infrastructure. For example, in the weekends, you're not doing anything, right? Why should you are not working? Obviously, most employees don't work. You can shut down infrastructure and save costs. That is not possible in a traditional data center business. There's a lot of services at 165 or more. It's always we grow, and so we have so many services to solve many problems. Obviously, this is, you can find this in the AWS website. Fortnite is runs on AWS. You also know this. This is also the Netflix runs on AWS. They use. I'm not going into details, but they use AWS services to kind of stream the video through AWS. Before I go further, any questions, anyone? Okay. All right. So how does it work in the cloud, right? For the interest of time, I have some screenshots. But basically, let's say you want a server, right? You just go and pick, okay, I need a Linux one, or I need a Red Hat. You just pick the flavor and then select as a 64-bit. And then what kind of CPU I need, how much memory I need, what is the storage I need. Again, I choose that. And I kind of verify networking security groups and what is the boundaries of it. I click launch, right? This is as simple as that. So this is almost like buying a shopping cart experience, right? I mean, most of you, I'm assuming, have not worked in the data center. If I have to, like an internal even data center business or data customers, you still use data centers. This sometimes could take months. It's as complicated as that for many other reasons. But the fact that you can do in minutes, it's a huge, solves the speed problem. It's a huge benefit for many customers. All right. Before I go further, any other questions, anyone? Okay. All right. So I'm just wanted to give some introduction to some of the developer tools. As you're hacking, you might see them, use them. Granted that I don't know how many of you have AWS free account or anything, but maybe not for this hackathon, maybe in the future. But we do plan to give some at least education credits, not usage credits, in the future. But this is just going to give introduction. So the first, I would say, more specific to infrastructure is Cloud9. Like most of you use some kind of an IDE. You may have to use Eclipse or Visual Studio. There's an IDE in the browser-based IDE that's available in AWS called Cloud9. So you don't need to install anything. It works with most of the platforms, and you can do many things with that, even including like you want to develop some icons and stuff. You can still do it. But pretty much it's IDE. We have Code Artifact. So it is an artifact management that is pre-built for you for software development. We also have Code Build. You're building and testing code, automating your build and test code. Also, we have Code Commit. We'll go through some of these things in detail. But also we have Code Commit, so which will help you with source code, Git repositories, and stuff like that. So if you really think these are not I would not call them as new innovations purely because Today, you'll have to build a server, install Jenkins, or install a script or a deployment platform. You have to get the software. Instead of you maintaining and babysitting the licensing and infrastructure, we have a service for that, right? So because of that, we just take all the heavy lifting from you, and all you need to consume or use this service. So you focus more on development and deployment as opposed to babysitting this infrastructure. Otherwise, you'll be building from scratch. Any questions? All right. So what is Code Artifact, right? This is an artifact repository service. Like when you do builds, if you go through build terminology, you may understand what an artifact is. So if you have any dependencies, it fetches them and from the public repositories, so that ensuring that your dependencies are latest, have the latest access to latest versions. It works with all package managers and build tools like Maven, Gradle, and there are so many other tools. So it's basically fully managed by AWS, and you just need to configure and use them, right? So the way it works is, it looks at the public repositories and it has hooks into it, but you can apply the policies if you have any specific policies for your company, and you can securely publish and store the packages for you, and developers will interact with them. And there's something called, as we talked about, Code Build. It's a fully managed continuous integration. If I use CI, continuous integration, in your development world, this is the service you'd use. You just point to this location of source code, put the settings, and it will do the build scripts, it'll do the compiling, testing, and packaging for a release. You don't need to provision any servers, any software, nothing. We fully manage it for you. It provides support for many other diversified technologies, but also you can build your own environments such as .NET and all those things as well. So we provide a lot of flexibility here. Code commit is basically another source code system, as I said earlier. It's securely stores your source code to binaries and works seamlessly with your Git tools. But most importantly, as I said, again, it's eliminates the need to operate your own source code system or worry about scaling. Because let's say your developers are growing, one day you will not have space, you have to build additional nodes or do a scale up. But here, the scaling, as your needs grow, you have elasticity behind the scenes to grow as well. All right, before we go further, any other questions? Okay, so just kind of a benefit. So we are going to give participants, we're just working on some logistics on that. Like we will get the AWS Educate code. So what is AWS Educate? Is basically is for high school students and educators. So where you can learn AWS, we'll give you a predefined path of from step-by-step ways to learn and get trained. And it is free for everyone. But we're going to give some codes which will extend the life, or you can use for more longer periods of time. So basically, based on your age or where you are, if you're an educator or you're in college, you have some career paths, and so that's pretty much on the AWS Educate. But the point is, in terms of what you can do today is. You can subscribe to AWS Educate, right? I'll definitely encourage that. And I just put a career path. I just wanted to kind of share that, but most importantly, choose a path, because the cloud is so vast, right? It's even in AWS, I will never know. I'm a coworker, Randy here, but there's 165 services, right? That you need to know the fundamentals. It's humanly impossible to know everything, right? So if you're a developer, you would focus on learning developer tools. If you're more into machine learning, you'll focus on learning machine learning specific services. So you don't need to, just because someone is machine learning, you don't need to learn that, or someone is learning developer tools, you need to follow that. Choose your strength, because based on your strength, choose the path, but you still need to have the fundamental knowledge of cloud, and but you can specialize on few services based on your need or your interest. I will never say that if you are a cloud AI ML, you'll be the best or you'll make a lot of money. That's not true. You will have some superpowers either in development or infrastructure. So mostly there are like 4 or 5 paths. It's infrastructure, development, maybe security, or like a database, or maybe like a machine, like a AI ML, data science, right? They're like, these are the common paths, but get the grounding or the fundamental knowledge of cloud, and then choose that fits your needs. So that's pretty much. It's not a lot. I would encourage questions at this time. As I said, there's no dumb questions. I'm happy to answer anything about what I do in AWS, but also how. If you have any other career questions, I'm happy to answer, or any other questions that you might have. Kara or Piero, any other questions for you? If you're interested in asking, you can just unmute yourself and ask. Okay. Sammy, do you have a better knowledge of cloud than where you were 40 minutes ago?
Yeah, I definitely think so. I think that clarified my main point of confusion. I'm definitely probably looking to AWS Educate. I kind of had a more offbeat or like fun-ish question to ask, and that was
sure. Sure, there's no. We'll not get offended, yeah. Please.
It totally makes sense that or whenever I hear infrastructure costs and that, the first thing I jump to is natural monopolies, and I think it's certainly a concern with how dominant Amazon has been in cloud hosting. So I just wondered if you thought there were any potential risks to the centralization that Amazon has gotten in this market.
It's a good question, but I cannot talk about monopolies or anything based on because I'm an AWS employee. But I think just to let you know, a lot of people come and ask me, I'll answer in a different way. Okay, you'll still get an answer. I can guarantee that. So, for example, today, only 15% of the companies, less than 15%, or let's say we give or take 5 to 15% of companies have moved into cloud. There is 85% of the people who are still in the on-prem data center. So what I'm trying to tell you is that the pizza slice, the pizza is so big, people have only scratched it. So there is still opportunities, and there's always competition, right? Like that other cloud providers, it's still going to be a big competition to seize the thing. So the customers of cloud, or the current customers, we only scratch the surface of this market. It's a huge opportunity still out there. I don't know about monopoly, but I feel that, personally, as I said, I work for Microsoft. There is an opportunity for maybe cloud provider. And then I think competition is only going to make each of the cloud providers better. That'll be my politically correct answer. Yeah, I can't complain, or I cannot really comment on what AWS is doing and not, unfortunately. Sorry about that. But as I said, there is an opportunity for every cloud provider, because the market is so big. And with COVID, everyone is digitizing their work, and there is even more opportunities, I would say. Randy, you want to add anything? I mean, not specifically the question, but anything about what I asked?
No, I think that what it's important to everyone to just in context, everything that Suresh talked about was a lot of things in the back end driving every tools that you use. Even what I see today, the Replit. That's driving, some backend systems are driving from the cloud. Again, it doesn't have to be AWS. It could be GCP, Azure, and all the like. I know, quote unquote, cloud is kind of like the foundational aspect, so it may not be as super exciting as using some of these tools, but they are being driven, on the back end. Think of even the upcoming one, the Echo AR. I think one of their and I'll let the person speak, but you're pushing a lot of the data into the cloud, so you're not necessarily running that heavyweight stuff locally on your devices. So spot on, Suresh. You wouldn't believe that a lot of stuff, transparently is in the cloud. So that's one thing to take away from this talk.
Yeah. As I said, we a lot of things we use, we take it for granted, right? Like, oh, things are running, but we cannot talk about that. But many things you assume you do, I do right now, we use runs in cloud, right? Because it is not a rocket science, but it is a complexity. So let me give an example. I used to work in EMC. So I built the EMC.com infrastructure. Basically, if you go to EMC.com, it was EMC, that has around like 102. Like it has the production or the one you see in it had around like 60 servers, and it used to take 7 months, 6 months to build end to end. Can you believe it? So the users and the developers used to complain and yell at me every day. Why are you saying 7 months? Right? It should not take 7 months. Right? So every time they want to build, we have to build, put the wires, put the cables, buy the storage, get the network, go to the IP address, get the firewall rules, get the memory added, storage added. It's almost like building pizza at home, right? And that would, if that takes 6 months, cloud is solving it in a minute. So at a minimum, we are solving the speed problem, right? Why should it take 7 months to build infrastructure? You will not believe that's the time it took. It is not anything, it was sequential process, and there was no automation because cloud forces you to automate. Because I can write a code to build all the infrastructure. I don't need to click the button, as I showed you. There's something called CloudFormation. We also refer it as infrastructure as code, where customers do it. The other piece is when I do installations manually, you can do fat fingering, right? I know, Jonathan, you build a lot of infrastructure. How many times you have fat fingered a configuration?
Wait, what does that mean?
Oh, okay. Fat fingering configuration is, let's say you want to type let's say you did Apache or web server configuration, you accidentally typed an extra character, and then you deploy it, but you'll fail, right?
Yeah.
Because you didn't use a script. But if you use a script to deploy the infrastructure, it is consistent. You will not fat finger anything.
Yeah.
Right? If you do it manually.
Yeah.
So, good.
Manually, I always run into issues, which is why I use scripts for everything nowadays.
Yes, exactly. That is what we have done. In my previous job, there were 7 servers. Someone went and typed extra character in one of the servers, and it was all behind a load balancer. But nothing was working. And we didn't know which server was having it, because one person, when he did it manually, had put an extra character. We lost a week. So cloud forces you to automate, because we have a software, just like Java. There is you can even automate with Java today, but it's basically you can write code to deploy the infrastructure. So this consistency, because if you think about Netflix or these big companies, they have to build hundreds and thousands of servers. If everyone has to go and click manually, you can never watch the next movie that comes in Netflix so fast, because everything is automated. Cloud forces, or I would say facilitates, automation at scale. So that's another benefit of going to cloud kind of platforms. So there's a lot of inherent benefits, because I kind of, even though I never thought I will be in this cloud business, I used to suffer a lot in the data center world, and I used to figure out how do we solve this problem? And then this cloud thing, I never would say I invented a cloud or anything. I was just attracted to that, because a traditional way of building infrastructure in data center, even today, is very time consuming and very complex. And then the cloud providers just simplify that for you, right? It just takes all the burden. Not to say that there are other things that happen and works. Like somebody said, in the cloud, you don't need to take backups. What do you mean you don't need to take backup? You still have to take a backup, right? The fundamental of software engineering is not going to go away. Cloud, AWS is not to take a backup of your personal data, right? You have to take backup. But the point is, it helps you, the cloud companies, just take the burden a lot from your plate. So that let's say for hackathon, if we had provided you all these tools, maybe that's the next thing we should do. You should be focusing on your ideas and implementation, not worrying about which server, which machine you're going to put it, right? So it'll be easy for you, even as a hacker. Don't you think, Sammy?
I'm sorry.
No, I was just thinking if you had provided you a cloud free AWS credits, it's easy for you to develop your idea rather than doing in your local machine or local servers. Correct?
Yes, definitely.
Yeah, that's the same idea. That's the same idea for cloud. So anyway, looks like I think I covered what I wanted to. I covered what I wanted to share. But if we don't have questions, we can adjourn and give back some time to you. But I trust this was helpful.
Thank you so much. I learned a lot.
Cool.
Thank you.
Thank you. Thanks, Kara. All right. Talk soon, guys. Happy hacking. But as always, any questions, reach out to their mentors, and then they're happy to help you. But thank you so much for listening patiently. Have a great evening, everyone.
Thank you.